welcome to the Inspirante podcast, where we talk with different guests about topics pertaining to education and career goals. My name is Aadit Sangwan. I am a founder and president of Inspirante Education. I am a senior in Limerick High School and have participated and founded multiple nonprofits. I have a strong passion for business, computer science, and design, and am a part of the business club TECA in my school. I also enjoy participating in sports as I am a part of the Limerick water polo team. Enjoy the episode. Hello everyone and welcome to the Inspirante podcast. AI has been around for decades, but what has accelerated its recent growth is the availability of data and the resources to effectively mine the data. It is believed that 2.5 quintillion bytes of data are generated every day, and also 90% of this data has been collected within just the past 5 years of humanity. One blog from IBM says that the data is the world's new natural resource, unleashed by the maturation of artificial intelligence, and holds the potential to generate economic wealth, health, and social well-being. With all this data we have at hand, the bigger the problems we can solve and the more powerful our solutions can be. Today we have with us Ms. Seema Saharan, an accomplished professor, software engineer, data scientist, and biostatistics researcher who is currently the lead instructor of the Berkeley Global Data Science Program. In this talk today, we will start from the basics of data science and learn some of the fundamental skills like structured thinking and analytical skills, which are equally important to develop in addition to proficiency in maths and statistics to build a strong foundation for data science. Welcome, Ms. Saharan. How are you doing today?
I'm fine. I'm good. Thank you for inviting me to your podcast.
It's a pleasure having you here. How has your quarantine been going for this past year now?
My classes are intense, so I'm busy, but I enjoy the challenge. I enjoy teaching courses like data science, machine learning. I love to program, so it's been good. The pandemic has impacted me and my students, but we are trying to be as strong as possible.
That's good. So, Ms. Saharan, let's start off with some basic questions about data science. What is data and data science in a simple language for our listeners?
Well, data, technically speaking, data is the rawest form of information. Data is information that we can obtain from people in the form of social media, images, click streams, etc. Then sensors in the form of streaming satellite data related to temperature, etc. And finally, from organizations such as CDC, SDSC, which is San Diego Supercomputing Center, which monitors phenomena like wildfires, etc. So that is basically data.
Mm-hmm.
And then I think you also asked me to define data science.
Right.
So data science emerged basically from the field of statistics. It is still continuously evolving. It is a domain that is an intersection of computer science, statistics, mathematics, and domain expertise, like medical field, etc. So data science enables extraction of insights from data that will direct real-time, evidence-based decision making. For example, wildfires models created by data science algorithms could direct evacuations or firefighters to focus their efforts in a certain region. So you can see how important this will be from the life-saving aspect. And artificial intelligence basically is the overarching ecosystem or umbrella which incorporates data science, machine learning, computer science, and all the other complex components that are part of this architecture.
So, is it safe to say that data science can be used in many industries, not just the tech industry?
That's right. Data system is all pervasive, it's ubiquitous, and it has proliferated all industry, parts.
Okay, so since data science is a growing field, a lot of high schoolers are interested in joining this industry. So, what should we high schoolers do if we're interested in exploring this field of study? And what are some skills that we can start building straight in high school?
If you're aspiring to work in the data science field, you should gain knowledge in the subject area of mathematics, statistics, and computer science. In the mathematical domain, you should gain expertise in algebra, calculus 1, and calculus 2. Now, some students might still wish to gain an additional competency. So their domain area might be slightly different from the core data science field. For example, you could gain knowledge or domain expertise in the biology field, but then you might additionally take up some of these subjects so that you can be a data science in the medical field.
What if they want to get involved in data science? Do you have any examples of projects that a high schooler can do in their own high school for that would involve data science?
Well, they, from the school aspect, they could, yes, they could get involved in a data science endeavor in any domain expertise of choice, like the biological data or the economics related data or the even the history related data. For example, if they have historical data and they want to extract or try to predict who wrote a specific text, if there is some ambiguity about who was the author of a text, well, they could do some textual analysis. The only issue or challenge is that data science is not a subject in its own right in high school. So they might have to take advisors like me or some professor who's already teaching this subject. Their own teachers might not, go into that pathway. So they could do a collaboration with their own teacher as well as an additional professor who is teaching this field or a researcher, right? And I think a lot of people volunteer, people like me, who will help high schoolers to achieve their objective as long as they wish to achieve it.
What is the relationship between computer science and data science?
Well, data science, you have to implement algorithms, right? And those algorithms, some of them originate from the computer science field. For example, there is an algorithm called classification trees, right? A classification tree is a hierarchical structure, and it is like a sometimes a search. And in computer science, we have searches like binary search, um, and many more searches through trees. So the basics of that search and the programmatic aspect comes from the computer science field. Now, how do we optimize the algorithm? What is the complexity of the algorithm? If you want to go in more details, or how can I fasten the algorithms? Well, that can only be achieved if you have the know-how of operating systems and also data structures. How do I optimize the data structures? So for a data scientist, it is important to have a good know-how of computer science as well.
Is there any specific language that all data scientists should know, or should you just have a basic understanding of the algorithms?
So, in this contemporary context, the two languages which are very prevalently used in the data science field is um, R programming language as well as Python programming language. These are also very popular because they are open source. So there's no cost to using it. The aside from enterprise development, general purpose development for research purposes, for small projects or projects that are, not deployed for big enterprises can be accomplished using the R programming languages and also Python. Uh, these both of these are object oriented. So, they are a offshoot of other programming languages, at least paradigm wise, right? Java, an object oriented language, Visual Basic, and other Microsoft related programming languages were object oriented. So, both these languages are also following the same trajectory, but they are more geared towards research and simplistic implementation. So they are not very difficult to learn, and they are very well adopted by universities and research teams to bring out the insight. So these are the two main programming languages. Now, if you look at it from the big data perspective, because we have a lot of data, as you had mentioned, in the current scenario, then we have big data programming languages, but then they are also emerging from these, like the PySpark technologies or Python libraries that gear us towards these languages or these analysis. So I would say, if you ask me what are the basic two or basic languages which are very important, well, those are our programming language and Python. But then we also have some very interesting databases that are used in conjunction with these.
You touched upon big data. What is big data specifically?
Well, big data has a few important characteristics. It has a few V's. V is for variety. That is, the data has a lot of variety. Velocity, how fast the data moves. That is the second V. So variety, velocity, then comes veracity. How truthful is the data, right? And then comes volume. That's another V, which is talking about how large, the data is in thousands and millions of petabytes. Um, and then the last but not the least is the value, V for value. How much value can we extract out? And as I told you, that the data can be extracted from lots of um, sources. But the important fact is, how can we leverage big data? That is the main question. So, can we build models for hurricanes or wildfires from the previously collected data? But then, can we also integrate it with the current real time data? Can we integrate it with the data that we're getting from our sensors? Can we integrate it further by the data that we're getting from social media, tweets about, say, a current fire that's going on? All those, can we integrate it and bring out the insights and build um, um, more, I would say, realistic or more valuable models which can help us save lives, right? So, translating the models and the real data in the current context and then building them to give us the real time views, so that we can either improve um, health of individuals, right, in the medical field, or could we develop more life-saving strategies like the wildfire scenarios. Now, even in the medical field, there is something called translational medicine, which means, can we translate our scientific research into clinical practice, right? For that also we need big data. We are going more towards precision medicine, where we have multifarious data in diverse formats of diverse biomarkers. Can we integrate all of that into um, something that will help us save lives?
I want to go back to the V's you mentioned. The second V was velocity. How would you measure the speed of data? Is it how quickly it transfers or something, or is it something else?
Yeah, mainly how quickly. So, how quickly is the data coming to you, right? The data coming to you. Can you, can you collect it? Yes, we do have computational power to collect it very quickly. but can we, on the, as it's coming, not only can we save it because it's unstructured.
Mm-hmm.
The aspect of big data is it's not necessarily going to be structured like an Oracle database data, right?
Mm-hmm.
So unstructured, it'll be clickstream, it'll be image files, etc. Can we not only you know um, collect it, but can we process it in real
Mm-hmm.
time and build those models or get those insights out as quickly as possible, because it's in the real time, it is when we are able to extract insights dynamically that we can help people.
Mm-hmm.
Okay.
Okay. So while we know that businesses, companies, it's no secret that these companies use data to make better decisions all the time. Uh, I think that we can use a lot of data in data decisions in our own personal life, just not in business decisions. How do you help your students learn and apply these skills, not only thinking in a business aspect but like in a personal aspect as well?
Students can adapt and adopt perspectives of data science for making life decisions. That is true, right?
Right.
To make holistic decisions, students should obtain data from diverse sources, right?
Right.
Process it judiciously before making any decisions. I counsel and teach students not to make decisions in a hurry, instead, gauge their choices, understand the trade offs before making informed decisions. Now, you do this on a daily basis. You would like to choose courses, right,
Mm-hmm.
in high school, or you would like to look at internships, right,
Right.
in over the summer. So you should first look at whole landscape. You should look at what is available to you, what is practical. Now this could be from the aspect of whether you want to go to do an in-person internship. Is it physically accessible? Then are you interested in it, right?
Mm-hmm.
What are the prerequisites for you for it? Is there a age prerequisite, right?
Right.
Is there a skill prerequisite? So you have to look at the whole landscape. Now it's very difficult to um, gauge all that in the brain at the same time. So, how about making a grid, right? How about collecting some data? Look at the reviews of that program, right?
Mm-hmm.
Look at teacher reviews, look at the student reviews, look at talk to individuals, go physically and meet somebody there. So that's also data. It's processing and making informed decisions. So yes, in your own life you can make those decisions if there's a real data on it, right, somewhere. Then you could even process that and see if that particular internship or that particular job makes sense to you. So not to have a marginal view is important. To have a more holistic, comprehensive view to make decisions is paramount. And I think that is important for students to think about. There will always be trade offs.
Right.
You know, nobody can get a utopian circumstance, but measuring and juxtaposing the advantages versus disadvantages is very important for you to come to a informed and judicious decision.
So, for students interested in research, which fields of research can these data science skills be applied to?
So there is a plethora of applications. I'm going to state some of them.
Mm-hmm.
Uh, I can tell you that it is it's not a tangible skill, but it is has proliferated throughout our society, throughout the world. So some of the applications of data science are automatic language translation, then medical diagnosis, then stock market trading, online fraud detection, virtual personal assistant, right? For even in the medical field,
Mm-hmm.
email spam and malware filtering, self driving cars, product recommendations, traffic predictions, speech recognition, right? Image recognition. So you can see um, this is just the tip of the iceberg. There is a lot of applications, and we can really leverage our progression, human progression, into the next um, era, by bringing out these in a way that will help society.
Do you have any examples of any research projects around data science that which you or you noticed a student may have done?
Well, I work as a voluntary data scientist at a cardiovascular lab, um, and this is in the UCSF Medical University. So UCSF is primarily a medical university where they, run labs, and these are pioneering labs doing research which is very innovative. I work with a cardiovascular lab, and they are working in the area of biomarker discovery, and they bring out new biomarkers. For example, we know the general biomarkers like age of a person, HDL of a person, LDL of a person, total cholesterol, etc. Right?
Right.
Um, this lab extracts newer biomarkers. I'll talk about a biomarker called cytokines. So, cytokines is an inflammatory biomarker. It is part of it's a biomarker which checks how much inflammation do we have in our body. Okay. And that inflammation actually is an indicator of a person's um, um, heart condition. So CAD is cardio vascular diseased person, and we also have a control group. So basically, these biomarkers can differentiate between the CAD group, the people who have heart issues, versus the control groups, and they are able to differentiate them at different levels, right? So I help them predict these individuals. We also have these are very sensitive biomarkers, so we can also check the progression of a person's heart condition over years. Now you know how the pandemic has ravaged the whole world. Um, Even the level of severity of COVID can be monitored by these cytokines. Okay. So, you know how different individuals have responded in a different way, right? Depending on comorbidities or other conditions. But cytokines can actually, if checked adequately across the disease progression, they can be very important indicators. Other tests are not able to inform us of the person's condition. Sometimes people have become complacent and they thought they will recover in a few days, and then they in fact became even more severely affected by the COVID virus. But these cytokines can actually give us more nuanced and more clear picture of a person's condition, right? So these biomarkers can probably help us preempt the severity of the infection. We might be able to chart therapeutic pathways and create therapeutic modalities even before the severity becomes so extenuating that we cannot save the individuals. Okay, so this is my research. I use machine learning data science algorithms like random forest. I've used k-nearest neighbors. I'm these days using regression to predict the different stages of coronary heart disease. I'm also working to show the efficacy of the cytokines in the smoking situation where cytokines can also differentiate people who have very severe smoking lung issues versus people who do not. So, it is used, we are going to actually use it even in the diagnosis of Alzheimer's. So you can see how important these new biomarkers are. Now, clinicians or doctors, when they work, they are able to collect this, right, data. They look at it from the cell molecular aspect, right? But they are highly appreciative of my contribution because I am able to extract out those nuanced insights which help them validate their own intuition, then also charter new, therapeutic pathways. That is what translational medicine wishes to achieve. We want to take our scientific research and translate it into clinical practice, right? And then also help in the precision medicine field, because precision medicine states that every individual is different, right?
Right.
We should be able to target and create treatment plans for every individual as per their own biomarker information. So, same thing, like if we have big data about, say, let's say, CVD, that is cardiovascular disease, we have a lot of data, big data. Can we use those models and integrate personal biomarkers with comorbidities, etc., for individuals, and then extract a pathway for an individual as per his situation and his biomarkers? Do you see my point?
Yeah. Okay. That makes sense. Okay, yeah, that makes sense. So that's one example of how data science is helping, and it's not just a small impact. You're making a big impact with this as well. So that's all the questions I have for you today. Is there anything that I missed upon about data science that you want to convey to high schoolers who may be listening to this?
Well, I have a very generic advice. Follow your dreams. If you are interested in the field, read on it, watch podcasts, look at the internet gives you a lot of resources. So search, be inquisitive, read, watch, and you will have a feeling of whether you want to go into this field. As I said, you can be a domain expert and then on the side, get a data science minor or a double major in the future, so that you apply data science techniques onto that domain expertise, right?
Right.
And then in general, I have this is just a saying from the internet which I pulled out, and I like to tell my students because I teach students of different institutes or universities. Always remember, you're braver than you believe, stronger than you seem, and smarter than you think. So do not underscore your own intelligence. Be confident. You will have to work hard, but you will achieve your objective. And if that objective is to be a data scientist, then you will surely achieve it as long as you work hard.
That is great advice. Thank you so much. Is there any way that high schoolers could contact you? Is there an email that you have that we could reach you at?
Well, my email address, my personal email address is ssaharan9@gmail.com.
Okay. So if you have any questions about data science, we can contact you there then.
Yes, you can contact me at my personal email.
All right. Thank you so much for your time, Ms. Saharan. I really appreciated this talk about data science and seeing how it's applicable in many ways and some more key concepts about it. Thank you so much for joining me.
Welcome.
Thanks for listening to our podcast. Follow Inspirante as well at Inspirante_education and follow our podcast on Spotify at Inspirante Education. Thank you for listening. See you on our next podcast coming soon.